Good morning friends, welcome to week 2 again. Now we will be discussing continuing the lecture 9. We have discussed till this point, as you can see on the screen, the binomial distribution and the Galton board, and we had discussed the use of Galton board and trying to draw the number of probability of an event happening in that slot of the Galton board. We also discussed that in earlier week 1 exponential graph, what is y is equal to x, and today we are going to understand the utility of this Galton board. Okay? Please understand. Now we will go ahead. So as you can see the red dots is for a 5 level Galton board. Okay? Irrespective of number of balls you increase, the shape will be like this only. Now as the n tends to infinity or as the number of trials increases, what is n in our case, in this case Galton board is the number of trial. Every ball has to decide 5 number of times whether I will go left, right, left, right, left, right, left, right. That is what we discussed in the earlier classes. Okay. Now here it is very important to understand, as the number of trial increases, the shape of these graph will approach to a normal graph. Please understand, when a binomial distribution where the probability of failure and success is same and the number of trial increases to infinity or goes a very high, if not infinity, very high, the shape will look like a normal graph. Okay, I have said that. Now I will show you what is the mathematical equation of a normal graph. This is a normal distribution. Just take a look. There is exponential function here. This is called a bell shaped curve. So this will, what the graph will become when the number of trial will increase. Okay. This is the equation, and I will explain to you this equation again. It is very elementary. Normal graph is the elementary basic of statistics. If we do not understand this, it will be very difficult for us to understand later subsequent things. Please, therefore, from now on our statistics journey actually is starting. We have discussed binomial distribution, now we are discussing normal distribution, and when the Bernoulli trials in binomial distribution increases or as the n increases, it approaches a normal graph. I am repeating it multiple times to make you understand why I took a complete session on Galton board, so that you understand what is a binomial distribution, and that will be going towards normal distribution. Okay, now let us explain to you what is happening here. We have discussed exponential graph y is equal to Ex if you go to week 1. Okay. Now you might be thinking what is happening here. Here in our case, exponential minus x minus mu square. So both terms are square. Okay. This is for a x either negative on the left hand side or on the right hand side the positive, that is fine. But what if I am drawing y is equal to e minus x? Okay. Completely mirror image. But what if I tell you I can draw one more plot which is combination of these two, which is taking this portion from here and this portion from here, which becomes so this is a graph of y is equal to e to power minus x modulus x. Modulus x, what is modulus x? modulus x, I will just tell you this basics, is the absolute value of x. If x is more than 0, this is x, if f is less than 0, it is minus x, it is minus x, which means modulus of minus 5 is 5, modulus of 5 is 5. So, now the exponential graph was not symmetrical, but the moment we write it at this way, y is equal to e to power modulus minus x, this graph will be symmetrical. This is not normal graph, please understand, but I am trying to relate to you from the exponential graph how we are step by step coming to this point. Okay. Now, this is one way. Now, this quantity is always positive, modulus always positive. So does square 4 times or power 4 power 2. So, any term square, x modulus is square positive. So, x square will also be positive. Okay. And if I tell you, okay, let us draw y is equal to e to power minus x square. Okay. Do not worry, we will use R console to draw these figures, draw these graphs in coming times. Okay. But first let us get the theory basics. So, either at shape will be little different, but it will be symmetrical. So, this is what we are going to use. Y is equal to e to power minus x square, or it is also written as exponential minus x square, or 1 upon exponential x square. Okay. So, this is the base, y is equal to e to power minus x square is the basics of this complete normal graph. Okay. If you remember, we have discussed standardized form. In a standardized form, we have the mean centered divided by the standard deviation of the data. Okay. So, why I am telling you that? Because if you see the thing x minus sigma whole square, this is z. Hence, if you see again, if I write this as 1 by sigma 2 pi. Now, how these values came, that is high end statistics, we will not go in that. This becomes ultimately exponential minus z square by z square by 2. Let me rewrite it again. Z square by 2, where z is this. So, again ultimately it is a demonstration of y is equal to exponential minus x square or minus x square by 2 x, that is a different thing, but this sort of graph will exist. Now, look at the notation here. We always write normal graph as n. Mu sigma. This is what it means by writing n as mean variance. Okay. And it is from minus infinity to plus infinity. Now, here I will tell you one more concept of asymptote. Asymptote. So, let us, this is again little basics, not to worry that much. Suppose I am drawing a graph y is equal to 1 by x Okay. Now, what is when x is 0? Y is infinity, and when x is infinity, y is 0. Now, as we all know, it is very difficult to describe infinity. So, we say as x tends to infinity, y becomes 0. As x tends to infinity, y becomes 0. So, as the x increases, the value of y will become more and more less, but because we can never approach infinity, so we can never approach y equal to 0. Like you might say 1 to power 10 to minus 2, then you might say 1 to power 10 to minus 4, or even y 1 into 10 to power minus 15. Now, 1 into 10 to power 15 is as good as 0. However, it is not 0. That is what asymptote is. Asymptote is a line which on extension will go towards 0, okay, but will never be 0. And similarly, on this side, as x becomes 0, y will, this is y tends to infinity, x tends to 0. So, as y is never possible to be 0, x is never possible to be 0. It is like 10 to power minus 16, 10 to power minus 20, minus 30, whatever you want to say, and y will tend to 0. So, this is called an asymptote. This is asymptote and this is asymptote. And these asymptotes are present in our normal graph. Please look at it here. On the left hand side here, on the right, the bell shape, it is there. So, this bell shape curve, which you will be hearing again and again in statistics, it is a bell shape curve, it is a bell shape curve. What does it bell shape mean? The bell shape is coming from the normal graph. If you change the sigma and mu, things will change. Okay. Now, we will come to console R, but before that we will again demonstrate something. Now, frankly speaking, it is very difficult to know what are these values. Now, what happens here, if I ask you that this is a normal graph, okay, get me the value of this normal graph at this particular point. Let us say x is equal to 5, where mu is 3, sigma is 2. Now, what happens? It is very difficult to calculate it mathematically on the basis of paper and pen. We need to go to higher end mathematics to understand this. Okay. Hence, predefined tables exist. Predefined table exist, and I will show you them. Predefined table exists to get these values. Okay. Now, please again come back here. Now, when I give you this thing, this predefined table will not be for all x, mu and sigma, it will be for only z. So, what I will say, my z is 5 minus 3 by 2 1. So, please tell me the value of the curve at z is equal to 1. Z value is very much used in creating the predefined tables. Okay? And as we discussed in the introductory week about probability, that the probability histogram, the histogram frequency based probability is based on histogram, and that transfers to the probability curve in a continuous domain. Okay. What does this value means? At that z is equal to 1, what is probability of event if it is following a let me rewrite if it is following normal distribution, then what is this probability? And that is what probability distribution is. Probability distribution is the probability of a event happening, and that event is x. So, p x is the probability of event x. Okay. So, that is what this value e to power minus z square by 2, as we have discussed here. You will put this in the formula, or the calculations, the tables have this formula feed it, and then the values are got. Okay. Now, coming back, this is mathematics of normal curve. What is the physical significance of normal curve and why it is been so much popular? Yeah. So, why it is so famous? So, why and it is called normal? It is not actually, the term is Gaussian distribution. The mathematical term is Gaussian distribution, but that Gaussian distribution is called normal distribution. Why? So, as we were talking, if we take heights of, let us say 1000 people, and we make all precautions that we are not just in some town or in some place where there are abnormal heights, or the average height is the height is very different from what is normally available. So, we are assuming, we are taking the world is uniform. Okay. You take 1000 people from any place, we are assuming that. Then when you take height of that, their heights will follow a pattern of, which means there will be some mean value. Okay. And as you go left or right, it will decrease. It will never reach 0 theoretically, because actually we have n tends to infinity, here we have n 1000, but the shape could be a representation or a small section of normal curve around the mean. Okay. So, if you take IQ, you take IQ 50,000 people, let us assume, you take weights of 50,000 people, the lab sample is very large. Then around the mean, the shape will be graph of like this. Now, the sigma and the mu will vary, and we will show you how does things vary when we have different sigma, different mu's. Okay. We will show you graphically in R console. Okay. So, please understand this. This is very important. Okay. So, now understanding the application of normal graph or normal distribution. The normal distribution is the distribution which applies to everything when the sample is large. If I take height, I take weight, okay. I can take income, I can take IQ, okay. We can also take immunity levels, okay. Therefore, you always have a range in the medical fields, the range of this, okay, and that is what is normal distribution, okay. Now, on the next class, we will go on practical application of the normal distribution on the R consoles. Thank you very much.